So for network hardware, we're going to talk about the network topologies, the network types, look at the different types of devices, the features of those devices, and where to put them on the network. So we're going to start out with this scenario where we've got 5 computers, and we're going to have a network printer, a scanner that's connected to this Mac operating system desktop, and then we're going to have a Ubuntu desktop with a local printer. So we've got this star topology because everyone's connected into the switch. So that would be a star topology. And then we're going to kind of go through it. And so we've got the big thing they want you to notice here is, and it is an important thing to note, we have a network printer and we have a local printer. So this local printer needs this desktop computer to be on. If you watched my previous video, I had a little story about, if your desktop isn't on, then you can't use the resources that desktop shares. So LANs and their hardware, when we talk about LANs, we mean local area network, and everything is connected, then can communicate over that network. And it's probably, LANs are considered a small area or a small space. So it might be an office or building. And so in our example, we had the 5 computers with the network printer all connected to the switch. Now, a LAN on a bigger scale, like at Rock Valley, we have different LANs set up. And there's many more than 5 computers, right? But the switch is just the item that is going to be the connector, and it's going to receive data from any of its ports that we have something connected to. So there's multiple ports, and the information is going to come and go via those ports to the intended destination on that network. So we've got our star topology, one central device, which is the switch, and everything's connected into it. If, for example, if you're like a bank, and because in a banking situation or in certain situations, people want you want to have redundancy just in case one link goes down. You do not want to ever have you always want to have access to your information. So the bank, like a bank or other places, the government, anything that's high importance, high value, you'd want a mesh topology so that everybody connects into everything else. The thing about a mesh topology is it's very expensive because you have multiple routes for everything. And so we got our switch. This is actually a really big industrial switch. Jim Conley and I, he retired, but we got a switch this big, and we were going to try and make it into a refrigerator because it wasn't worth anything. It was so old. But there are new switches that are this big. But most of the time we see these. And these are the ones, like this one here is the one that I have in WTC 2100. That's what we use for our Cisco networking, something similar. And then there's a little small 8-port switch. And I use these in my high school class so that we can create little networks and little areas. Usually we end up, we connect and we share information. And then at the end of the year, we can do some gaming in our classroom. Hub is something that's old and outdated. So it's inefficient, outdated. Switches are really cheap. I mean, I bought a switch like this. I mean, they're really inexpensive. I can't even tell you. They're very cheap. You can buy them for under $50. So in the whole scheme of things, they used to cost a ton of money. Now, and that's why we used hubs. Now we could use switches. So a hub was something that transmitted information and repeated the signals, but it was very efficient, it was very slow, and it used to be the central point, but now the switches have kind of upgraded everything. So they've now replaced it. And with switches, we can actually greatly reduce the traffic because when a switch receives any information, it sends it to the destination. So it doesn't just broadcast it out. So a hub, so the difference is, let me go back to this picture. Anytime any of these information, so if the Windows 10 computer just wants to print, if this was a hub, it would send it to everybody. It just broadcast it out all ports and not care. In a switch situation, the switch actually thinks about it and goes, oh, the Windows 10 device wants to send it to the network printer, and it will only send to the network printer. So it doesn't have all this extra, so we don't have all this extra traffic flying around. So we just have the switch will send it exactly where it needs to go in the local area network. Much more efficient. So we don't use hubs anymore. But we always talk about legacy information or legacy networking because that's some of that older technology. We build upon it, and not everybody has the new network. And I always say, I mean, I kind of pick on Alaska, but to me, they're kind of like the branch off into nowhere. It's kind of a good picture in your mind that they might just have kind of like off into older technology. They have, they're kind of isolated, I guess. So it's my example of an isolated network. I probably shouldn't use that as an example, but it's an isolated network, and sometimes they don't update their information. And there might be reasons why, but as a network technician, you just have to be prepared for everything. And if you're not, you need to understand how to look things up. So we go through it, we kind of understand things, so at least you can have in the back of your head, well, hubs, that's old technology. So if you come across that and you're like, oh, what's this? And somebody says a hub, you at least know that you might have to look that up to see what to do with it. And hopefully you can replace it if you have to, if you're having issues with it. And let me tell you, working for a school district, we had old technology, we had new technology, we'd have grants and have really cool equipment come in, and then we'd have this old technology, and then we'd have to run to the speed of the old technology. Very frustrating, but it gave really me a lot of experience with that. So, okay, so we got an example here on a laptop. All of the computers have, whether they have a wireless network card or a wired network card, they'll have one of the two on there. My laptop I have has a wired network card, and it has wireless. So the laptops might have double duty. My desktop, same thing. It's got both. I'm not currently using. If I had a preference, I would use wired. Wired's faster, more reliable, just all around good. So, and then sometimes you can install them into an extension slot. You can buy a USB network card. I've used those before. You can actually put them into a desktop. So we've got a gigabit Ethernet adapter. They actually list the MAC address on it. Usually I don't really look at the card itself to get the MAC address. I go into the operating system to find it just to double check, because it'll always be there too. So here's the network card. Here's where it shows the MAC address. And the MAC address is burned in, so it's always on that network card. So that's how you know it's a MAC address. It's burned in, always on that MAC card. MAC card, or network card. The other thing is if you have a more complicated network, you might have multiple switches, and they might be kind of daisy-chained. I call it daisy-chained, but it's really network background. So we've got these three switches, and then they're connected with the network backbone. So not background, I said that earlier, but the backbone here. And so you kind of see. And then this is this local network. We have our three switches. This is hybrid. And they're daisy chained together in a single line and uses the bus topology. So it's kind of a hybrid topology. So it's kind of like we've got a bus topology, but we also have star. And then we've got our hub and spoke, and we've got this one. So we've got this switch in the middle that has multiple networks connected to it. Legacy network is a ring topology. So we had it's kind of like a circle. So they're connected in a ring, and we've got two neighboring nodes, and it can pull data along the ring. It can only talk if it has the token. So you use this in a small group, and it passes that token around so that they can talk. And, it's kind of like, it's kind of similar to, like if you're sitting around a fire and you're playing a game and you can only hold on to like a stick or whatever to talk, and then you're passing that stick around, but you'd pass it in a circle. It's not used anymore. This is slow. It's vulnerable to failure. If one fails, the whole entire thing fails. So we don't really use it anymore. And then we have, we'll add in a router now. So we use routers. So like in our home network, we use routers all the time. And really it's a router with a switch. So this home router here has a switch connected to it. And that's really what it's like. So we've got this home router that connects us to the internet, and then we immediately connect into a switch in order to communicate. See, here's our combo device. We've got the wireless with the switch. So we've kind of got the router and the combo device all in one. We're connected through an ISP or an internet service provider. My ISP is Rise Broadband. They've been down for a while. It's been up and down, and now they finally got their information, or their servers up and running, I guess I should say. And so our internet service provider is the one that gives us connection to that network, to the internet. I actually get, they send a combo device along with kind of like the device that, because I have Rise, it's a little bit different. I can plug my phone into it. So they have two different devices. And so mine kind of looks like this, where I have the home router, and then they connect to, they gave me a mesh Wi-Fi system with Wi-Fi 6 to put into place. But I already have a Nighthawk system that I like, so we'll see what I use. 3 LANs connected by a router. So here we've got 3 LANs connected by a router. Now, a business router is totally different than our little combo device or our router we have at home. So I'm not going to say totally different, but it's definitely beefier. It's better. And so it's definitely got purpose. And it's going to be much better for business purposes, and it's going to cost more. I think I just bought one. Oh, gosh, what did I buy? About in the summer, I bought one, and it was $1,500. So that was a low end one because I'm using it for my Cisco classes, and I think I got an educational discount as well. So, and the switch was $2,000. So the high end switches, we've got consumer switches and routers versus high, business grade. So the business grade's a little more expensive. And that's not even the high end business grade. If you go look them up, they can be pretty expensive, especially the Cisco stuff. But the Cisco stuff, it doesn't seem to die. They work really well. So router might also be referred as a gateway device or just a gateway. So when you go to your PC and you type in your IP address, subnet mask, there's also a gateway that you can plug in. So any of the PCs, their gateway is going to be the router interface. And that's what we learned in Cisco as well. So any host, I'm going to keep going up and down, but the picture is really nice. So any host, so any one of these PCs is an endpoint device. And then, so a node, so the host is an endpoint device. The node is going to be the router or switch. It's connected to that network. So hosts are network devices. Cisco, we kind of go with end devices. That's just what we call them. And then our networking devices are routers or switch, which is what I'm used to calling it. I don't really ever call a router or switch a node, but you might see that somewhere. And then we also call them intermediaries. So anytime you have like a device in between, which could be a router or switch, that's an intermediary devices. So hosts are end devices or endpoints. And then nodes are intermediary. I don't know. And then we've got, reason I say I don't know is I probably would just use end device and intermediary instead of node. Host is still good, but it's that node that I just don't care about. A group of LANs, so we've got multiple local area networks, is a wide area network. And the internet is a network of networks, right? So it's the wide area network. Sometimes you'll have a metropolitan area network, man, or you can have a campus area network, or CAN. And then we have our personal area network. So sometimes I don't generally use these because these are just basically kind of like bigger areas. And so like NIU, they have multiple campuses. They have the big campus in DeKalb, but they also have Naperville, and they have a campus, I think, still in Rockford. And so they have multiple areas that they connect to. So for sure, they have a campus for engineering in WTC. So they have an area there. They have, I know they work with Sauk Valley College. They try and work with as many community colleges as they can. And so that would be their campus area network. It's kind of, it's a little bit bigger than a local area network. Metropolitan area network might be multiple buildings or government offices. The example I have of a metropolitan area network is the Cisco campus. So Cisco Technologies in San Jose. So Cisco has their main campus in San Jose, California. And I don't know if we can see all of them. So we have our Cisco buildings here. So this is Cisco building Q. We've got so many different, they've got so many different buildings. Like they've got almost all of this area, except for, like the University of Silicon Valley. But Cisco Systems has this whole area. Look at all of these buildings. And when I was there 12 years ago, they had A through Z and then AA, AAAB, AC. So they were going all the way. I think they were at LL at the time. So I'm sure they have more buildings. We'll see. But they have so many different buildings. So this would be a metropolitan area network. So, we've got, square miles. We've got miles and miles of buildings that Cisco has. Let me go back here. I went too far. And then our personal area network, which is just a small network, and it's just all our personal devices. So like when we're syncing with our smartphone. So I have a Pixel phone. So I got, with a Pixel 8, you were able to get a free watch. So I've got my watch, I've got my phone, I've got, I think I got a speaker set up to it, and just many different things that you can connect to the, just your little area network that you have there. And so they show just kind of like the sizing. This just kind of shows us the sizing of it. A WAN connects two LANs. So like and this is exactly what it is for Cisco networking or HP or any of the big companies. We've got multiple LANs in one area that go across the wide area network to get to the, might be just another extension. It might be, so we might have multiple divisions in different areas. So this one happens to have a Philadelphia office, and then we have the San Francisco office. So they're connecting through the WAN, and this could just be anywhere. We got body area network, our personal fitness devices, and that's kind of what I was talking. I really call that a PAN, but storage area network. This is, at one point I had a whole class on this. It was a great class. I love teaching it. And so we talk about setting up a storage area network and the devices that you need for that, and just backing up to that information. And then we get the wireless area network, which is just 2 or more devices connected wirelessly. And so we talk about each one of these later again too. So this first chapter is all about giving you like the basis of everything, and then going back in and talking about them in chapters coming up. All right, the OSI model, that will be the next video. So we'll go over 1.4 or 1-4 in the next video.